So I chose a couple of the free response questions that I posted last week sometime for us to take a look at. I really sincerely hope that this is not the first time that you are looking at these problems. My intention is that you have all at least tried the problems, at the very least looked at it to the point where you would think about possible strategies. Maybe you've tried something, maybe it's worked, maybe it hasn't, and that's okay. Hopefully, at least you've tried something. For this one specifically, I, I know from looking at this one and working with students in the past that there may be some people who did part A who are going to become angry with me when you see how easy part A can be. If you did part A by taking a whole bunch of derivatives, well, I guess we'll put that in the category of learning the hard way about how to do these problems. But that's part of this exercise, is to try things out and figure out what works and figure out what doesn't work and figure out what things can be done easier. So I guess that's where I would like to focus today. Um, so this is the 2011 question. They give us this nice graph that is the absolute value of the fifth derivative, but they don't really tell us why they're giving that to us. They say that f of x is defined as sine of x squared plus cosine of x. And then we've got the graph of, again, the mysterious fifth derivative up on the top. Part A says write the first four non-zero terms of a Taylor series. And here's where I really hope that you didn't derive this from scratch. This is a series that we know at this point. They asked for the first four non-zero terms. That's not the fourth degree term. That's the first four non-zero terms, because for a sine function, we end up with a lot of zero derivatives in between these terms. Anyway, if you don't know this series, get to know this series. Sine of x, cosine of x, e to the x, 1 over 1 minus x, and inverse tangent of x. Those are the big five, really big 4 plus 1. E to the x, sine of x, cosine of x, and 1 over 1 minus x are the big four. I throw inverse tangent in there just because it has shown up on the AP test in the past. Anyway, there we go. So that is sine of x. They asked us for that, and then they also asked for the first four non-zero terms of the Taylor series for sine of x squared. And so I just replaced all my x's with x squareds. I didn't take derivatives. I didn't build this from scratch. I just used what I knew about the sine function. So there we go. That's part A. Part B, let's see, write the first four non-zero terms of the Taylor series for cosine. Here we go again. That's a point. I can guarantee that that's a point just for knowing what that is. And then the rest of the points we're going to get on this one come from, let's see, what we found in part A, to write the first four non-zero terms of the Taylor series around x equals 0. So we've got sine of x squared from part A, we've got cosine of x for part B, and f of x is just, well, one plus the other. So I combined like terms. There was only one constant term, 1. There were two different terms that had an x squared. There was x squared from the sine function, sine of x squared, and then there was x squared over 2 minus x squared over 2 from this one. So I put those together as one term. This was the only x to the fourth term. And then this one came from the sine of x squared term. That must have been the third term of that one. Or maybe it was just the second. Well, either way, we got that one from the previous, and then minus x cubed over 6 factorial from cosine of x. And they wanted the first four non-zero terms. So I've got this term, yes, this term. This is the second degree term, fourth degree term, sixth degree term, and those are our four terms. I don't know if they would require that you do the simplification step, but I chose to do it just so I would have something plus something x squared plus something x to the fourth plus something x to the sixth. I can actually almost guarantee that they wouldn't need you to simplify this one if you left it as this form right here. You would get credit for it. But when I was doing part C, it became clear to me that knowing what this coefficient was going to come in handy. But if you're just looking for the points on part B, that's all you need. In fact, I believe part C was only worth 1 point. So if you're with me so far, you've got 8 of the 9 points so far. The sixth power term is going to be useful for us finding this. And this is the general form for a Taylor series. And that is that the sixth power term is the sixth derivative at 0 divided by 6 factorial times x to the sixth power. So by writing it like this, by writing that term like that, I've got it sitting right in front of me. This is the sixth derivative because it's divided by 6 factorial times x to the sixth power. So negative 121 is my answer for that part. And then part D, I didn't even copy over because that's the part that I told you that you could skip. Lagrange multipliers, or excuse me, Lagrange error bound is not something that's on there. And that is actually the only reason that they gave us this graph in the first place, for something that we don't need to know this year. So um, I'm not going to talk anymore about that one. The next question that I wanted to take a look at was the 2013, mostly because that was the next one on my pile. And so that seemed like a good one for me to take a look at. Hopefully you've looked at it already. Hopefully you've thought about it. This one's more of a general form of a Taylor series kind of a question. Let's see, they tell me that P sub n is the Taylor polynomial for f. They give me the value of the function at that point. So that tells me the first term of my Taylor polynomial. And then they tell me that my polynomial at 1/2 is equal to -3. Now, this is an nth degree Taylor polynomial centered at x equals 0. And so you see, I actually even started writing something down here, and then I decided that I should go with the general form. The first degree Taylor polynomial is the value of the function at that point plus the first derivative times x. And we'll see with part B what happens when I need more terms than that. And so at x equals 1/2, the value of this function is -3. That's what they're telling me. So I plugged in 1/2 for x, I set it equal to -3, and the only thing I did not know there was the value of the first derivative at x equals 0. So a little bit of algebra away from solving for that. They even were nice to us, and they didn't say find what the value of f prime of 0 is. They said show that f prime of 0 is equal to 2. Generally on an AP test when they do that, that's a good hint that this information is going to be used on either part B, C, or D, and they don't want you to lose points if you can't figure out what that is. So there it is, f prime of 0 is equal to 2. The good news is that we know that's right because that's what we were told. The bad news is that we have to show work, a significant amount of work. If you just say f prime of 0 is equal to 2, obviously you get nothing for that because they're saying show that. So we need to show the steps that lead up to that point. Part B, it is known that f double prime of 0 is equal to -2/3 and f triple prime at 0 is equal to 1/3. Well, we know that this is the first degree approximation, the value of the function, the value of the derivative times x. And so I'm just adding on to that. The value of the second derivative over 2 factorial, it technically is factorial, but you don't need to write the factorial. A lot of times they'll have you go to the third power term just to make sure that you're not forgetting that that's a factorial and not just a 3. Here again, I don't think that you would have to simplify. I just have a hard time sleeping at night when I've left fractions inside of fractions. So I did simplify this to be this as my third degree Taylor polynomial. And then I moved on to part C that I didn't leave myself a whole lot of space to work on the PDF that I had printed off. And so let's see what we're doing here. They're telling me what the derivative of h looks like. It's f of 2x. And since I found most of f of x in the previous problem, I feel pretty good about plugging in 2x to that. And then the value of the function at 0 is equal to 7. And they want the third degree Taylor polynomial. So I said since h prime of x is equal to f of 2x, let's just use what we found in part B, plug 2x into that. And so this is h prime. They want me to find a Taylor polynomial for h. So I'm just anti-differentiating term by term. Similar to the problem that I did in the homework questions video that I published earlier, there's a plus c at the tail end of this, but I just put the c at the beginning of it because then I've got these ellipses at the end as the tail at the end of it. But antiderivative, 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 they only wanted the third degree Taylor polynomial, so that's where I stopped on this one. I use the fact that h of 0 is equal to 7 to say that something minus 0 plus 0 minus 0 plus a whole bunch of 0 has to be 7, which means my constant of integration is 7. And there we go. The only picky little detail, I don't think this would be a big deal on the actual AP test, is that they asked for a third degree Taylor polynomial for h. And so I just used a notation. I said that this was the third degree polynomial. I stopped it at the third term. I think you probably get away with this as your answer for this problem. Okay, so there we go. Um, between now and Thursday, certainly, please, 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 if you have not looked at the rest of the free response questions, take a look at those. Practice. It's okay to get frustrated with these problems. It's okay to not know immediately what to do. Part of what we're doing is learning how to uh, know what the first step is, learn when we should be taking derivatives and when we should just recognize what it is. Uh, so keep practicing this, keep working on this. Certainly, if there are questions, get in touch with me. If there's something specific that you would like to see on Thursday, but these free response questions are what you should be doing. And by the way, you've got access to them. They're all floating around on the internet. So if you want to do more than just the ones that I've got published, go ahead and look for them. In fact, it's probably a pretty good bet that if you start looking for questions on the internet, you're going to find questions that are going to end up being on the test on Friday anyway, and that wouldn't be the end of the world either. So keep working, keep asking questions, and I will see you next time. Bye bye.